So in this problem, aluminum sulfide is reacted with water to give these products. And what the question asked is, what amount of aluminum sulfide remains when 20 grams are reacted with the 2 grams are reacted? So if, as it says, there is going to be remaining aluminum sulfide, water must be the limiting reactant. So the procedure is going to be figure out if we have 2.0 grams of H2O, how many moles of product can we make? And we'll use the H2S product because it's easiest to calculate. And then once we know that, we can go backwards to figure out how to make that much H2S, how much aluminum sulfide does it take? So here's the calculation. We're going to make that grams H2O units go away, and we'll make that moles of H2O, and that's 18 grams per 1 mole. And then we have to cancel moles of H2O and convert that to moles of H2S. Okay? And from the stoichiometric ratio, 3 up there, 3 there, 6 here. So when I do that calculation, the amount of H2S I make is 0.056 moles of H2S. Now, that's how much we make. So let's find out how much aluminum sulfide it takes to make that amount. So 0.056 moles of H2S. And now we've got to make this into grams of aluminum sulfide. So we're going to make moles H2S down here, convert that into moles of Al2S3, and that is 3 up here for this, and the aluminum sulfide is a 1, so those unit cancel, and then we have to go to grams. So just put moles of aluminum sulfide down here, grams of aluminum sulfide up here, and that's given to be 150.17. So 150.2 grams of that, and then I do the, and so that calculation turns out to be, so I start with 20.0 grams of the aluminum sulfide. I consume, to make that much of my H2S, I consume, that calculation showed it to be 2.80 grams, and I'm left with, well, the number I get is 17.2, and that's very close to 17.22 in the calculation here. So that's how you do that one. Now, of course, your numbers may be different, but that's what my numbers gave me as an answer. So for, this is Chapter 8, Question 33, non-algorithmic, number 23 in the list. I'm going to react 14 grams of calcium with water, and it is going to produce calcium hydroxide, and I'm going to get this 5 grams out. Use the following balanced equation, which I've written down, to calculate the percent yield. So remember percent yield. What we need is an actual yield divided by the theory, how much we should get, yield, times 100%. And what we're given here is an actual yield. So we have this top part. We need to calculate what the theoretical yield. So if we start with 14.0 grams of calcium, how much calcium hydroxide should I make? And this is in grams, so we need to make that in grams. And so it's going to be the calculation where we put grams of calcium. Down below, we put moles of calcium on top, put in the molar mass, or the formula weight. Cancel moles of calcium, go to moles of calcium hydroxide, which is 2 there. And then we have to get rid of, that cancels those units, that cancels those units. And then we have to go and get rid of times, put mole calcium hydroxide on the bottom, and make it grams of calcium hydroxide on top. And then you do, that's a 2, and you calculate that molar mass, and then you calculate what the theoretical yield should be. That's the number of grams you get. That's what's going to go in right there, divide it into 5, multiply by 100, and you get your percent yield. And I'm out of time on this video, so I'm going to stop there, but that's how you do it.